Hi class, today we're going to start our chapter on polynomials, and so we're going to need to know a few terms that are going to be very important as we go through this chapter. These are words that you may not have heard before, but may have possibly seen things that were what these items are, and we need to give a name to them so as you're reading your problems you know what they're talking about. And once we get through these terms, we will be adding and subtracting polynomials today. So the first item that we need to know what it is a monomial. And a monomial in layman terms is basically just letters and numbers multiplied. So in the past you've seen things like 2x, that was a monomial. If you saw just the number 5, that was a monomial. If you saw 3x squared y cubed, that was also a monomial. So each of those things that we have in the past just called a term is actually a monomial. So now that brings us to the next item that we need to know what it is, and that's a binomial. And mono means one, bi means two. So what a binomial is it's two monomials added or subtracted. So when you saw expressions before that were like 2x plus 5, that was a binomial because it was two terms and they were being added. Or if you saw something like 5 minus 3x squared y cubed, that was also a binomial because it's two terms that are being subtracted. And that kind of brings us to the next item that we need to know what it is, which is a trinomial. And we kind of have patterns in math, since mono meant one and this was one term, and bi meant two and there were two terms. Tri probably means three terms, and that's exactly what it is. It's basically three monomials added or subtracted. So if we put all these together as 2x plus 5 minus 3x squared y cubed, then you have a trinomial. Now, when you're writing your solutions, no matter whether they're binomials, trinomials, or what we call a polynomial is actually any of these items here, or anything that has more than three terms, because not everything is limited to 1, 2, or 3 terms. So we call a polynomial basically any of these items that we're going to be looking at. And when you have a polynomial that has more than just one term in it, so it's more than just a monomial, you have a certain order that you want to put these items in. The preferred order is this descending order, so I'm going to put a star next to it here. And I'm going to just show you what descending order is. When you think of descending, you think of going down, and that's exactly what it is. To put something in descending order, you want to find the first letter in your polynomial, that as when you look in the alphabet, what is the first letter that would come in the alphabet in your polynomial. And in this polynomial here, x is the first variable that would show up in the alphabet. Then what you want to do is find whichever term has the highest exponent for that variable, which would be this term here. Now, if there were two items that had an x squared, as an x squared was your highest, then you would look at the y's, which would be the next letter in the alphabet. But you kind of ignore the y's unless you have two x's that have the same exponent. Here we just have one that's an x squared, and because it's subtracting 3x squared y cubed, this is really a negative 3x squared y cubed. And since this is the highest exponent, that needs to go first in order to be in descending order. So we will write a negative 3x squared y cubed. And then you go down to the next highest exponent. And when you see something like this that's just an x and there's no exponent here, there's always an implied 1. If at first you need to write that 1 in there to remind yourself that it's there, go right ahead and do it. But you do want to eventually wean yourself off of doing that. Since this is a positive 2x, we're going to put plus 2x. And then The next item we have is a 5. The 5 doesn't have any x's, so that's like having an x to the 0. And later in further videos, I'll show you why it's really an x to the 0 next to it. So finally, on the end, you put your constant, which is just your number. This particular item here is now in descending order. Ascending order is the other order, and sometimes your problems will actually ask you to be in ascending order. So ascending, when you say that, you think of going up rather than going down. So really all you have to do for ascending order is take your descending order and completely flip it around. So instead of negative 3x squared y cubed plus 2x plus 5, you're going to start with the 5 and then have the 2x and then the negative 3x squared y cubed. And that would be ascending order because we start with the lowest exponent and we go up instead of starting with the highest exponent and going down. Now, the last thing we need to know what it is a like term. Like terms are things that you can combine. So in previous things that we've talked about, we might have had like a 2x and a 5x. We were able to add those because those were like terms. They were like terms because they both had the same variable, and those variables were raised to the same exponent. So 2x plus 5x we could combine, and we got a 7x. You can only combine like terms. So like terms need to be things with the same variables and the same exponents. If I had a 3x and a 7x squared, those would not be like terms, because one had a square and one did not. If you have more than one variable, you have to check all the variables. So if I have a 5x squared y cubed, and let's say I have a 6x squared y, these actually would not be like terms, because if you look at them, the y here has a 3 for an exponent, and this one just has that invisible 1. So those would not be like terms. If I had a 3 right here, then they would have been like terms. But the variables have to match and the exponents have to match. So those are your basic terms that you have, and the things that you'll need to know in order to be able to know what the problems in your textbook are asking you when you're dealing with your polynomials. Now let's take a look at how to add and subtract polynomials. We're going to start with adding. Let's say that you have a trinomial that is 8x squared minus 5x plus 3. And you're adding to that a 7x squared plus 9x minus 5. Now I'm going to show you two different ways to do the same problem. You can choose whichever method you like the best. So the first method that we're going to do is what I kind of call the crossing out method. Basically what you do is, since we know our answer has to be in descending order, we glance through all of the terms for both of them because we are adding, and it doesn't matter what order you add in. And you find the highest exponent, and the highest exponent is a 2. So we see if there's another x squared here anywhere else, and here we have a 7x squared. So since those two are like terms, we combine them by adding them. So 8x squared plus a 7x squared is 15x squared. Once we're done with those, we go ahead and cross them out. That way we don't look at them anymore and we know we've taken care of them. Then we glance through everything and we look for the next highest power. And we have an x to the first power. We have a negative 5x here, and it's negative 5 because the subtraction symbol goes with the number and tells you the sign of that number. This one over here is also an x. It's a like term, and it's a 9x. So what we want to do is combine those two terms. So I have a negative 5x. I'm going to combine it with my 9x, and when you add those together, you get a positive, so I'm going to put a plus 4x. Since I've combined those, I'm going to cross them out so that I don't look at them anymore. And finally, the only thing left are constants here, and a positive 3 and a negative 5 is a negative 2, so we'll put that on the end. And that's your answer, and because of the process we went through, this answer is already in descending order for us. Now the other way to do this problem is instead of crossing things out, you take your first polynomial, which is this one, and you put it in descending order, which would be 8x squared minus 5x plus 3 because it was already in descending order. As you do that, you do want to also make sure that you have every exponent accounted for. So notice we go from 2 to 1 to none, and our exponents on our x. So that's going in descending order and everything's accounted for. On the next example, I'll show you what I mean by making sure they're accounted for and make sure that one of them is not there. Then what you do is you take the next polynomial, which is this one here, and you line it up underneath strategically so that all the like terms are underneath the other polynomials like terms. So for instance, I'm going to go ahead and put my 7x squared underneath my 8x squared. I'm going to put my positive 9x underneath my 5x because those are like terms. And the negative 5 underneath my positive 3. Then you draw a line and do things just like old-fashioned addition that you did in grade school. So if we take a look at these, 3 and negative 5 makes negative 2. Take a look at these, negative 5x and positive 9x makes a positive 4x. And then take a look at these, and 8x squared plus 7x squared is a 15x squared. Notice we got the same answer. It was just another way of doing the problem. Now let's take a look at one that's a little bit more difficult. For instance, let's say that we have 7x minus 4x squared plus 2. And then we are adding to it 3x squared minus 5x cubed plus 1. Now, for this particular one, let's say that you decided you liked what we call the vertical method, which is the second method I chose where you lined everything up. So if we wanted the vertical method, then what I would do is start with this first polynomial here and put it in descending order, which notice this negative 4x squared needs to go first. So I got a minus 4x squared. Then I need to put my 7x because that's my next exponent. And then I need to put my positive 2. This is in descending order. Now I need to go to my next polynomial, which is over here. And the highest exponent here is a 5x cubed. And it's a negative 5x cubed because of the minus in front. What I'm going to do is put that negative 5x cubed out front here, because if this particular one here had an x cubed, that's where it would be, is out here. If you want to insert a 0x cubed in the first one to signify where the x cubed would be, that's fine, because if you have 0 of them, you don't have any of them, and that kind of holds your place for you. Now let's look at this one here and see what's next. We have a 3x squared. It's positive, so we're going to put a plus 3x squared right here. And then notice that this polynomial doesn't have any x's, but I do need to leave a space right here for where x's would be. And again, if you want to insert a 0x there to remind you of that place value, go right ahead, because there aren't any x's in that second polynomial. And then finally I have the 1 here, which I will put on the end right here. Now I can draw my line and just add straight down. The 2 and the 1 makes a positive 3. The 7 and the 0 makes a 7x. If we look at the next two terms, a negative 4x squared and a positive 3x squared makes a negative 1x squared, or we can just write that as negative x squared. And then finally my 0x cubed and my negative 5x cubed makes a negative 5x cubed. So notice that this is basically just a way of organizing things for you to get yourself in descending order for your final answer, and also to combine your like terms and get them matched up. That's all there is to adding. Now let's take a look at subtracting. Something that you might have to subtract would be, say, this polynomial of 5x squared minus 3x plus 2. And let's say you were subtracting from that 7x squared plus 2x minus 4. What we want to do is kind of remember back to our last class. In the last course you took, we discussed that when you had a subtraction right in front of a parentheses, that when we used our little rule of going to each of these subtractions and changing subtraction into adding the opposite, that since there was nothing right here, we could insert a 1. So what we did was we changed the subtraction to addition, and we inserted a negative 1. And then we distributed that negative 1 across the parentheses. The result of doing that was just that the signs in the second parenthesis all were changed. So for instance, this 7x squared turned to a negative 7x squared, this 2x turned to a negative 2x, and this negative 4 turned to a positive 4. Now that we've moved on, we can actually bypass this step because we know what's happening in this step. And rather than distributing everything, we can graduate to just taking this subtraction and changing it to addition, and then change every sign to the opposite of what it is through the entire parentheses. Now, notice I did this in a different color. I did it in red. If you have colored pencils, it will help to do this in a different color so you can see that step happening. Now that we've done that, we can just combine our like terms. Let's use the crossing out method this time. Our highest exponent happens to be an x squared. I have a 5x squared here and a negative 7x squared there. When I combine those, I get a negative 2x squared. Then if I look for, or cross those out, and then look for my next highest exponent, my next highest exponent is a x to the first power. I have a negative 3x here and a negative 2x there. Let's go ahead and combine these two, and that will give me a negative 5x, and then cross them out. Then let's take a look at what's left. I have a 2 and a positive 4. 2 and 4 make 6, so I'm going to combine these two to make a plus 6. Now we've taken care of everything in our problem, and our final simplified expression is this right here. So with subtraction, you basically just want to change the subtraction to addition and change the signs of everything in the parentheses following it. And that turns it into addition, and you just add like terms. Let's try one more of these. Let's say that I have 3x minus 5x cubed plus 6 minus 4 minus 2x squared plus 5x cubed. Let's first change our subtraction to addition and change the signs of everything inside the parentheses following it. Notice that I changed my 4 from positive to negative, my 2 from negative to positive, and my 5 from positive to negative. Now we can go ahead and combine like terms. My highest exponent is my cube, and I have a negative 5x cubed and a negative 5x cubed there. So I'm going to combine these two to get a negative 10x cubed, and then cross them out. Now let's glance through the entire problem and find the next highest exponent, which is a square. And we only have one square. It's just a positive 2x squared. So we're going to go ahead and write this down as plus 2x squared and then cross it out. Now let's glance through what's left. The next highest exponent is this positive 3x. And there's no like terms, so we're going to write this down next as a plus 3x and cross it out. And finally, we have our constants of 6 and negative 4. If we combine these two here, we will have a positive 2 and everything has been taken care of, so your final answer is right here. And that is all there is to adding and subtracting. So you're ready to try problems on your homework dealing with adding and subtracting.